All right, so we're going to work on solving a system of equations using substitution. And so the first thing you always want to look for are either the equations already solved for one of the variables. And if yes, we're going to skip to the substitute and solve. So we can skip this isolate box. If not, which variable should you choose to isolate? We always want to look for in this system right here, is one of the variables already solved for? If not, are there any single variables, or any that have a 1 or a -1 with them? And so this one, I'm going to rewrite this one in this box. So y equals 6x minus 11. And so that's the one that the variable is already solved for. And so since I wrote the top one in this box, I'm going to write the bottom equation in this other box. And so negative 2x minus 3y equals -7. Okay, so then here's where the substitution comes into play. This box right here is equivalent to the y. And so this box is the same thing as a y. And so I'm going to take this box and I'm going to plug it into the y on this other equation. And so I'm going to have negative 2x minus 3, right? Everything just as it is. But in place of that y, we're going to insert this box, 6x minus 11, and equals -7. And so the reason for doing that is you can't solve an equation that has two variables, but now we made it both be one variable. There's only an x in this equation, and so now we can go through and we can solve it. And so we're gonna, next off, we'll distribute this -3 to everything in the parentheses. And so the negative 2x is gonna drop down, and then -3 times 6x, you can use your calculator if you need to, but that's negative 18x, and then -3 times -11 is positive 33, equals -7. And so then from there, we'll combine like terms and solve for x. And so my negative 2x and negative 18x make a total of negative 20x plus 33 equals -7. And then we want to get the x all by itself. So we're going to subtract the numbers to the other side. Anything you do to one side, you have to do to the other side. It's going to drop down your negative 20x is equal to -7 minus 33 is -40. And then last step, we'll divide by the number in front of x. We're going to divide by -20. And that gets rid of that. And so we get x is equal to, that's 2. And so then my last step is we're going to substitute and solve again. So this first equation that I had up here, I'm going to put in this box as well. I'm going to put it in both of these boxes. And so y equals 6x minus 11. But now my x is equal to 2. I'm going to plug that 2 in for my x right here. And so y is equal to 6 times 2 minus 11. And now we'll evaluate. And so 6 times 2 is 12 minus 11, and 12 minus 11 is 1. And so that's my x value, and that's my y value. So my answer, my final answer, I'm going to put it as an ordered pair, is 2, 1. And so that's all the work for it. And now let's do it again. All right, so for my next one, we'll do the same process. I'm going to start off by saying, is there a variable that's going to be easiest to solve for? It can be x or y, but I want to look for one that may have a 1 in the front or a -1. And so this is going to be the easiest variable to solve for because there's no number in front of it. And so I'm going to write the bottom equation in this first box right here. And then I'm not going to write that one yet. Now I want to isolate. I want to solve for the x. I want to get the x all by itself. So to get the x all by itself, I want to move the y's to the other side. And so I'm going to add 2y to the other side. So those are gone. And I have x is equal to 2y plus 11. I'm going to go ahead and write this in this bottom box over here on the right side for later. So x equals 2y plus 11. We'll use that later. But since I put the bottom equation in this box right here, I'm going to put the top equation in the next box over here. And so negative 7x minus 2y is equal to -13. And then this box, like we did on the last problem, this box is equivalent to x on this one. And so I'm going to take this box and I'm going to insert it in place of the x. And so that becomes -7, and in place of the x, I'm going to put in that box 2y plus 11, and then insert the rest, minus 2y, equals -13. And so I kept all these numbers the same, but in place of the x, I put in that 2y plus 11, put in that box. And now, again, we're going to distribute the -7, so it becomes -14y. -7 times 11 is -77, minus 2y equals -13. Then we'll combine like terms. So that becomes -16y minus 77 equals -13. And then we'll add the 77 over to get the y by itself. And so that becomes -16y is equal to, and we add that together. That's negative and a positive. You can use your calculator if you want. Let's see, that's gonna be 64, I believe. And again, if you want to, you can use a calculator. -13 plus 77, 64. And then we'll divide by the number in front of the y. And so y is equal to -4. And so we got our y value. Now we'll take that y value and we'll plug it into the y right here to figure out what the x value is. So x equals 2 times -4 plus 11. And so x equals 2 times -4 is -8 plus 11. And -8 plus 11 is 3. So my x value is 3 and my y value is -4. There's my ordered pair right there, 3, -4. All right, moving on to the next one. Let's do it again. And if you're feeling more comfortable, go ahead and pause what I'm doing. Try and do it on your own, and then you can see how your work matches up with mine. But for this one, my y is already solved for right here, so I'm going to go ahead and put y equals -2. Here's one thing that's nice. There's no x right here, which is great. And so now I'm going to put my bottom equation in this next box. 4x minus 3y is equal to 18. And we're going to plug in this -2 for my y right here, because that's what my y is. It's equivalent to my y. So 4x minus 3 times -2 is equal to 18. And so 4x, -3 times -2 is positive 6 equals 18. And then we'll subtract 6. So 4x equals 18 minus 6 is 12. And then we'll divide by 4. So x equals 3. There's nothing to substitute and solve. I don't need this box. I have my x. I have my y. So my x value is 3 and my y value is -2. So this one's a little bit easier because the top equation didn't have an x and a y. It just had the y. And then my last one over here. All right. So for this one, I wouldn't solve on top because there's numbers in front of the x and the y, but on bottom you could solve for either one of these x or y. I'm going to solve for this y right here because it's positive. And so I'm going to write the bottom equation right here in the isolate box. And then I want to get the y by itself. And so to get the y by itself, I'm going to move the x over. Since it's a negative x, I'm going to add the x over. So that becomes y equals positive x plus 3. All right, so then this box again is equivalent to the y, and so since I use the bottom equation, I'm going to put the top equation in the substitute and solve box. So -3x plus 3y is equal to 4. That's the top equation. And then this box is equivalent to my y. I'm going to plug it into my y, and we'll evaluate for the x. We'll solve for the x. -3x plus 3, in place of the y, I'll put x plus 3 is equal to 4. And then we'll distribute this 3. So -3x plus 3x plus 9 is equal to 4. And then we have -3x plus 3x. Those actually cancel out. You don't have any more x's, and you're left with 9 equals 4. And so when stuff like this happens, this is called one of our special cases, where our answer is either going to be infinitely many solutions, all real numbers, or it's going to be no solution. And so for this one, does 9 equal 4? Well, no, that's not true. So on this one, our answer is no solution. These two graphs never intersect. These are parallel lines that will never touch each other. And that finishes up our notes. And so let me know if you have any questions.